So what we're going to do now is we're going to look at the state of stress. And so the complete state of stress would be what's called a stress tensor, which is 9 different stresses that we're looking at. So let's go and look at our just general blob of material. This one right here, it's got 1, 2, 3, 4 different loads on it. And so it is causing a bunch of internal stresses. And how do we calculate those out? Well, we take the slice till we get a flat plane inside of it, and then we sum up all of the normal stresses, we sum up all the shear stresses, and we run that limit equation. So remember, we defined, let's change out of this red, we defined that normal stress in the x direction is the limit as delta A approaches 0 of all of those infinitesimal forces in the x direction over delta A. And so what we did is we also defined shearing stresses, which were stresses along that plane. So we have tau xy, so the tau in the x direction on the y plane is the limit as delta A approaches 0 of all the shear forces in the y direction that's on the x plane divided by delta A, and then shear xz, so the x direction on the z plane. And then what we have is, actually, sorry, this is the x plane, that's the one that we're on in the y direction, the x plane in the z direction. That is the limit as delta A approaches 0 of the shear forces in the z direction on the x plane, delta A. And so this is where we came up with our entire definition of what stress is and calculated that out. Now, one thing I do want to point out is this sigma x, the normal stress, is a relatively recent notation change. Probably about 30, 40 years ago, this would have been listed as tau xx, and it would have been the tau, the force in the x direction on the x plane. Sorry, the x plane in the x direction, and it's recently 40, 50 years ago, been changed to sigma sub x. And so that's where we get, sigma x, we take that limit, it's going to be f over a, tau xy is going to be that limit, and so our shear force is in the y direction over a, and tau xz, the shear force in the z direction over a. So those are the equations that we've been playing with. So if we reduce this all down to 1 cube, so if we make all of our slices and we get this to 1 cube, our general state of stress is going to look like this. So on each, we have like a 6-sided die. On each plane, we're going to have a normal stress. And then on each plane, we're also going to have 2 shear stresses. So if we look at this, we've got 6 faces on this cube, and then we have 3 forces on each face. So that puts us at 18 different stresses. Now, everything is in static equilibrium. So what does that tell me? Well, that tells me that whatever sigma sub y times the area is on the bottom, it's got to be the same thing on the top. And so what that does is that reduces us to 9 unique stresses, because everything has to balance out. But since the moments also have to be completely in line and balanced, what's going to end up happening is we're going to find that this tau yz here, zy, is going to have to be the same as this tau yz, because the moment created by this force has to counteract the moment created by this force. And so for each one of these shear forces, we can spin the variables, and we're going to have the same exact shear force. What am I left here with? Xz. So those are all going to be the same. So now we've reduced that down to, we've got 6 unique stresses. So we have 6 components that completely and utterly define the state of stress that we have at any point. And so when you've got, so that's 3 normal stresses and 3 shear stresses. Now, what a stress tensor would be, we don't really talk about it in this class. The stress tensor is, tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, and then tau zx, tau zy, tau zz. Now, obviously, the xx, yy, zz, those are all the normals, and then, this is the same as this, but still, this would be the complete state of stress, the complete tensor. We do not do stress tensors in this class, so that's not really, it's more of a definitional thing, so if I say it again, you know what I'm talking about. But the important thing is for every state of stress, x, y, and z, normal stress, tau xy, tau xz, tau yz. Those 6 stresses will completely define any state of stress that we have. All right. If you have any questions, please let me know. I'll see you in the next video.